this video, we will discuss about longest square streak in an array. You are given an integer array nums. A subsequence of nums is called a square streak if the length of the subsequence is at least 2, and after sorting the subsequence, each element except the first element is the square of the previous number. Return the length of longest square streak in nums, or return -1 if there is no square streak. So what they're saying is that in the input, you are given an array. You need to find out a subsequence of this array. Now, what is a subsequence? A subsequence is nothing but a part of the array where you can take any elements from the array while maintaining its relative order. Meaning, if I took this 4, then after 4, either I can take 3 or 6 or 16. I can take any number. If I'm taking 16, I can skip these two numbers. The only thing that matters is that the relative order of the elements should be maintained. Meaning, if I have taken 4 and 16 and here 4 is coming before 16, then in the subsequence also 4 should come before 16, right? So that is a subsequence. Now you need to find out such a subsequence of this array whose length is at least 2, that is, it should be greater than 1. And if whatever subsequence that you have got, let's suppose A1, A2, A3, after sorting, right? Whatever subsequence have you got, after sorting it, except for the first element, all rest of the elements should be the square of their previous element. Meaning, if this is a subsequence after sorting, then in this, A2 should be the square of A1, A3 should be the square of A2, and A4 should be the square of A3. So this is after sorting, right? So whatever are the subsequences that are holding all these properties, out of those, whichever has the maximum length, that you need to return as your answer, whatever is the maximum length, right? So in this case, if you see that one of the subsequences is 4, 16 and 2, right? Now if you will sort this, what you will get? 2, 4, 16, right? Now check whether every element is the square of its previous element or not. So this 4 is a square of 2. Yes. 16 is a square of 4. Yes. So that means this is one of the valid subsequence and its length is 3. So in this case, this is one of the valid lengths. You can find all such subsequences and whosoever has the maximum length, that is your answer, right? That is your longest square streak, right? So now if you see here one thing, that when we had selected this subsequence, right, then we had sorted this to check all these, right? So whatever was the original order of these elements in the array, that is distorted now after sorting, right? So then that means we do not have to worry about the order of the elements, right? We just need to select some of the elements from this array and we need to check this property after sorting. Right. So you can select elements in any order because after that you are going to sort it. Right. So what I am saying is that what if we sort this entire array beforehand? If we'll do that, then it will become easier for us to identify such a subsequence, right? Because when we will sort this, then for any number, its square will always be present towards the right, right? Because square will be greater and it will be sorted. So the square will always be present towards the right, right? So what I'm saying is we will sort it beforehand. So when you will sort this, what you will get? 2, 3, 4, 6, 8 and 16, right? This is the array that you are getting after sorting. Now, how are we going to solve this? So let's remove this. So now if we see here, our first element is 2. Now we need to check whether this 2 can be a part of any subsequence or not, right? So now if you see here, for this 2, can this element 2 be a part of a subsequence except the first element? Meaning, can 2 be A2, A3 or A4 in any of the subsequence? No. Why? Because see, A2, A3, A4, they are always the square of their previous numbers, right? So see, this A2 equals to A1 square. Can this be written as underscore of A2 equals to A1? Or I can say A1 equals to under root of A2. Can I write it like this? Yes. Now for this 2, if you see, if you will do the under root of 2, then you will get some decimal number, right? Because 2 is not a perfect square. So then that means 2 can never come as A2, A3 or A4 or any element in the subsequence. It can only be the first element of the subsequence, right? Because these properties we are checking for A2, A3, A4. For A1, we do not have a previous element, right? So since this 2 is not a perfect square, it can only be the first number in a subsequence. It can never be any other number in the subsequence, right? So then that means when we are at 2, we can have a subsequence of length 1, right? Where the first and the last element is 2 itself, right? Then if you come at 3, now again 3 is not a perfect square, right? Because under root of 3 is also some decimal, right? That's why. So for 3 also, 3 can only be the first element in a subsequence, right? Now when you come for 4, now you need to check that can 4 be a part of any of the subsequence, right? So why we are doing under root here? Because when I am at this point, right, I have traversed all these numbers are still unknown to me, right? So if this 4 is there and I have traversed all these elements, then that means if this 4 is a part of some subsequence, then it will be a1, a2, a3 or a4 something, right? So if let's suppose it is a3, then for finding out a2 I will have to do the under root of a3, right? Only then I will be able to find out a2. That is why we are checking the under root, right? So if you see 4 is a perfect square, right, then that means it can be a part of a subsequence as a element in between, like except the first element. It can be the first element also, but it can be these elements also, right? So now if you see what is the under root of 4, that is 2, right? Now is 2 already present in your array? Yes, it is present. And we saw that for 2, we are already having a subsequence of length 1, right? So now this 4 can also be added to that subsequence. Yes, right? Because for 2, the subsequence was this. And now if you add 4 here, right, then you will see that this 4 is the square of 2. Then we can add 4 also. So for 4, the length became 2. Meaning there is a subsequence of length 2 where the last element is 4. Right. Now when you come at 6, now 6 is not a perfect square. So for 6 also, our length can be 1 till now. Then for 8 also it is not a perfect square. So for this also the length can only be 1. Then for 16 you will see that 16 is a perfect square, right? Under root of 16 is 4. Now is 4 already present? Yes, it is present. And for 4 we had already taken a subsequence of length 2, right? Which was 2 and 4. So can we add 16 here? If we add 16 here, then 16 is the square of 4, 4 is the square of 2. Then this is one of the valid subsequence, right? So what will be its length? So till 4, the length was 2. Now we are adding one more element. So now the length will become 3. So we have a subsequence of length 3 where the last element is 16. And now we are left with no elements. Now you know that these are all the lengths of all the subsequences where the last elements are these, right? Now, if you find out the maximum of these, then will you be able to get your answer? Yes, right? So out of these, which one will be the maximum? 3, right? So we can say that from this array, we can obtain such a subsequence of length 3, right? Now, if in case the largest number out of these comes out to be 1, right, then it will violate this condition, right? In our subsequence, the length should be at least 2. And these numbers are denoting the length only, right? So if the maximum length is coming out as 1, then that means such a subsequence is not possible. So in that case, you can return -1, right? So what we did was, first of all, we sorted our array, right? After sorting, we got this. Now, we checked for every element. We checked that if this particular element is not a perfect square, then that means it can only be the first element in any subsequence. So for this, we will keep the length as 1, right? So for storing these, you can use some map, right? In the key, you can store the number, which is the last number in your subsequence, and in the value, you can store the length of the subsequence, right? So for 2, you check that, okay, it is not a perfect square. So for this, the subsequence length can only be 1. So corresponding to 2, you wrote 1, right? Then you checked for 3, again, it was not a perfect square, then you wrote 1. Then for 4, when you encounter that, okay, this is a perfect square, then what did you do? You check that the under root of 4, that is 2, is present or not. So you can find out in the map whether that 2 is present or not. So you saw that, okay, it is present. So then whatever will be the length corresponding to that 2, you will consider that and you will do +1 in that. So that will become the new length for 4, right? And if in case the under root of 4 is not present in the map, then that means it can only be the first element. So in that case also, you will keep 1 as the value corresponding to 4, right? We need to repeat the same process for all the elements. At the end, we can iterate in the map. We can find out the maximum length. We can check that if the maximum length is 1, then the answer will be -1. Otherwise, whatever is the maximum length that we are getting, that will be our answer, right? So we will be looping in this array, and then we will be finding out elements from this map. So what will be the time complexity? So it will be n log n, right? And since we are taking a map here, so the space complexity will be big O of n, because we are storing all the array elements in this map, right? So I hope you got the problem. Let's code it out now. So first of all, we need to create a map. So let's create an unordered map which will store both the integers. Let's name it MP. Then what we need to do, we need to sort the nums vector, right? So sort nums.begin, comma, nums.end, right? After sorting this, we will iterate inside our vector. So it will give us a number. So int number in nums. Now inside this, what we need to check? We need to check whether this number is a perfect square or not. How you will check that? So first of all, we will find out the square root of this number, right? So we will use the sqrt function and we'll pass the number inside this. So you will get the square root of this number. Now you can check that if you do the square of this square root and it is coming equal to the number, then it is a perfect square, right? So one is this condition that the number should be a perfect square, and the other condition is that if it is a perfect square, then is it present in my map or not? Is the square root of this number present in my map or not? So in MP you will find whether square root is present or not. So it is not equals to mp.n. So if this is the case that this is a perfect square and its square root is also present in the map, then in that case we need to update the length of subsequence for this particular number, right? So what it will be? It will be the length of the subsequence for the square root plus 1, right? Otherwise, if the number was not a square root, or if it was a square root but its root was not present in the map, then in that case we will update the length of the subsequence as 1, right? After doing this, we need to find out the max streak or the max length. So initially it will be 0, then we will iterate inside our map. So we will get a key and a value which will be the length, right? So inside MP, we are going to iterate, and in the max streak, we will update the maximum of max streak, comma, the length, right? And at the end, while returning, you can check that if the max streak is 1, then in that case, return -1. Otherwise, return the max streak, right? So let's run this now. So the test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.